In this video, we're going to look at accessing MySQL in a Spring Boot application. Now, there are several ways in Spring Boot that we could access a database. What we're going to do in this video is to use the standard Java JDBC concepts that we described in the previous video. There are better ways that can be used in Spring Boot, and we'll look at those in later learning blocks. Before we can access a database, we need to create it. In this module, we're going to use MySQL, and it's easily obtained if you have XAMPP. If you don't have XAMPP, then download it from this link and then open the control panel. Then you can click on the Start button for MySQL and also the Start button for Apache. When both of those are running, then click on the Admin button for MySQL, and it will open up in a web browser window the PHP MyAdmin, and that will give you a web browser window onto your MySQL database. Then you click on New to create the database, and in that box you type the name of your new database. Click Create, and then you'll get your database created. So in PHP MyAdmin, you'll see that. If you expand it, you'll see that there are no tables. Now we want, in this example, to have a book table. So you can go to the SQL tab in PHP MyAdmin and type this SQL command, and that will create the book table. It will appear in the list under Library, and you'll see the columns as they are defined here. Now that we've got a database, we're ready to begin the Spring Boot project. So in the Spring initializer, which is at start.spring.io, fill in the information on the left, picking Java and an appropriate version. And then in the dependencies, you want Spring Web, JDBC API, and MySQL driver. And those are the dependencies that will allow us to build a RESTful application, to access the JDBC functionality, and to use that accessing MySQL. In IntelliJ, we want to set up the application properties. So in the resources, which is under src main, you'll find the application.properties file and add in this information here, which is the URL for your database, the username, which will probably be root, and leave the password blank, unless when you set up your database you provided a different username and password. This will be useful to us because it means that IntelliJ will be able to access the database that you created a few moments ago. We're going to be accessing the book table, which will have several rows, and we want to represent this in our Java code. So we're going to have a class called book that will hold the same fields as we had columns in the table. You'll see that I've got a constructor method that will allow me to set the ID and the title, these two values here, using these two parameters. And then there's a get method for each of those fields. So a very simple class at this stage. Now we want to write the RESTful API. So we're going to have some endpoints to get books, create, update, and delete. We're also going to generate requests so that we can test those endpoints. These are the two files that need to be written. So let's go into the IntelliJ project and take a look at those. Well, first of all, here's my application class, which is the standard one already generated for me. So now we want to write the controller class. There's the annotation for REST controller. The mapping is going to be just book, and then we can write code that will query the database or do other things with the database, all for books. So let's take a look at each of these endpoints in turn. This is just the standard default endpoint, so there's no additional path information. And all I'm going to do here is just return a string to say welcome to the MySQL example. For the next one, we're going to have an endpoint whose path is book/all. and the method we'll call allBooks, and it's going to return a list of book objects. So we'll create a new array list and store that in our local variable, which is of type listBook, and then we want to connect to the database. Now, get connection, if I hold Control and then click, will take me down to this method lower down in the class. And so you'll start to recognize from our previous video some of the things that we've got here. There's the URL for the database. We want to load the MySQL driver. That will then give us access to drivermanager.getConnection using that URL, and we then return the connection that comes from there. So let's come back up to allBooks. So we can get the connection to the MySQL database. We want to prepare a statement, select star from book, execute the query because it is a select statement, so we use execute query. And then while the result set has another row, at least one more row to process, let's load the next ones. So that's what rs.next does. And for each row, we're going to create a new book object using, from that row's ID column and title column, those values that come from the database, put that into a new book object, and then add that new book object to the list. That will iterate once for each row in the result set. When we finish the loop, we finish the result set, so we can then close the connection. And finally, return that array list of books. So that's going to query the table, get all the books from the book table, put them into an array list as book objects, one for each row in that result set, and then return the list. The next endpoint is going to be similar. At this time, the path, remember, if we just minimize this for a moment, the path for the controller is book. So this is going to be book slash and then an ID. This is our path variable. What we want to do is to get a book that matches the ID here. So by using this annotation at path variable ID, we're saying that this parameter in the method is going to hold the value from the request, and we're going to return a book that matches. But if that ID doesn't exist, we'll return null. So we're going to set our local variable book to be null. We're going to call that getConnection method again to give us a connection to the same database. But this time, our SQL statement is going to be select star from book where ID equals and then a question mark. That's the placeholder. And we want that to be a value that comes from this parameter up here, which is the value that was provided in the URL request string. And we're going to set that value into placeholder number 1. So let's say that the ID was 12. Therefore, the parameter value is 12. And so this becomes select star from book where ID equals, and because of that statement, we take the 12 and put it here. So now that will say select star from book where ID equals 12. Then we can execute the statement, and that's going to return either an empty result set, in which case rs.next will return false, or it will return a single row in the result set, in which case we'll get one of those that returns true. So instead of using a while loop, which I could have done and that would have iterated just once, I'm using an if. If there is a row to process, then create a new book object, store it in that local variable here, close the connection, and then return that book. So book at this point will have one of two values. Either we'll find the ID, that is, we'll find a row in the table that matches this ID, create a book object and return that book, or there will be no row in the table that matches this ID. Therefore, we don't do any of this, and so book still has the value null, and we can return null. If we want to create a book, so the path name is book/create, then we need some data to use for the book. And in this example, I'm going to use a request body to provide the value for the title. So we're going to insert into book just on the title because the ID is automatically generated. And the values, well, there's only the one placeholder. So I set that to be the value of title, that parameter there. Then we can execute update, check that the number of rows is not 0, because if it is 0, the message is book not created. If it is not 0, then we'll get the book ID using title and con. Now, get book ID is just going to do another selection, but this is a different selection. And we're going to query the database again to get an ID for the book where the title is the one that we've just been given. And that will return the book ID back up to here. And so that will allow me then to output the message book created with ID, and it's whatever that ID is that comes back. So create book is going to have two interactions with the database, one to perform the insertion and the other to get the ID of that newly inserted row, and so on. I think by now you should understand well enough what's going on. So we've already looked at get book ID. So if we want to update the book, we're going to update the title. Very similar way, but only where the ID equals a value. So this time we've got two placeholders, number 1 and number 2. So in number 1 we set the title, in number 2 we set the ID, and then we execute the update. If we want to delete, so we'll have our path, our full path will be book/delete/ID, using the path variable annotation to make sure that this parameter gets the ID value from the query. And then we're going to delete from book where ID equals ID. And then we can do the update. And so that's the controller. Now, in terms of object-oriented structure, this is terrible, but it's our first attempt. And it's showing in one class all the interaction with the database, making use of the standard JDBC interactions that we looked at in the previous video. This is not the best way of doing it, but I want you to understand the basics that we're looking at now, because when it comes to using better ways in Spring Boot, we still need to understand what's going on in the background. And what we're doing in this example is precisely what will be going on in the background when we use the other better ways. Now, to test all of these endpoints, I've written a generated requests file and I've put it in here. So if we open that up, we've got a whole load of requests that we can send in. Here, for example, we're going to get book 1. Here we're going to update a book, and we said that we wanted to use the request body. So here is some content type that is a JSON string. Don't forget the blank line. And there is the object, which is an ID of 1 and a title, book 1 updated. We want to delete book number 3 and get all books and so on. So we can use those when we run our application and just run those generated tests one after another. Now, if at some point you want to reset the database after you've done your testing, then you can run these SQL commands in the SQL tab on phpMyAdmin. Drop the book table and then recreate the book table. So we've looked at that example code, and hopefully you've been able to see how it all works. In the next videos, we'll look at better ways to interact with a database from Spring Boot.